Hi there, my name is Gavin Nielsen and we are cranking through Micromouse Modeling. So last time we split up the motor driver subsystem and encoder subsystems to kind of stub them out, and this time we're going to hop in and we're going to do the whole HBridge and PWM controller. So without further ado, let's jump in and do that. So because we're now kind of getting to the system modeling aspect of things, we could put it in situ right away, but we won't be able to test it because we need everything else to test it, to help test it. So what we're actually going to do is start a new model, and we'll build up our little submodel within here and test it out sort of as a unit test, and then we'll put it back in. You'll find yourself doing this a lot, I think. So the first thing, let's take a look at our HBridge driver, and a couple things I want to talk about that don't matter and a couple things that do matter. First of all, we want to make sure that we don't have more than 1.5 amps. It's rated at 2 amps. I want to make sure it doesn't get more than 1.5. A couple other things, our output for our motor we're going to have at 6 volts, so we'll keep that in mind. This is dependent on the voltage regulator you connect to it, so it can be 2.7 to 10.5 volts. We are not going, even though this is going to use a switched signal, and I think it's rated, if we scroll down here just a little bit, it is rated to 50 kilohertz, I believe. Scroll down just a little bit more and we'll see this. Anyway, I don't see it real quick, but that's what this particular HBridge controller is rated, the switching frequency. But we don't want to model every single switch. That would be a waste of simulation time and far faster than the mechanical system could respond. So we're going to say, hey, that's good enough. And I'll show you how to be in the averaged, more simplified mode. But we do need to model explicitly the bridge control decay mode stuff. So there's a little bit of logic decoding to do here. So let's do that. That's one thing we need to get going here. So if you haven't seen an HBridge before, basically it's just a set of switches that look like an H that you often put around a motor, but it's basically when you need to reverse directions on things. So if we look down here, we can see it's when we want current to go this way through the motor, let's say this is the positive direction, then we have it in this configuration. When we want it to go the other way through the motor, so it's going the opposite way through the motor this time, maybe that's the reverse direction. So that's what we're modeling. And again, here is our little truth table. So what I did was I actually, here we go. I'm getting ahead of myself a little bit. So first let's put the HBridge in there. We've got a lot to do, and so I'm going to go a little bit fast, but fortunately you're watching this as a video, so you can slow it down and reverse it and then repeat different things. So I'm going to get into Simscape, Electronics, Actuators, Drivers, and the Driver section, and lo and behold, there is such a thing as an HBridge. So that's good, we need that. We also need the controlled PWM voltage. Okay, so let's get these guys kind of expanded so we can see what they are. And they do actually connect to each other. And remind me, I wish you could remind me, we've got to lock this to a reference or ground, and we need to lock this to ground too. So let's get these things configured the right way. We could do it in high fidelity PWM mode. We're going to switch it to averaged mode, and we could look at the unsmoothed or discontinuous load current characteristics. We're going to leave it smoothed for efficiency's sake. Okay. Now the input thresholds are here you can see a little bit better. When this PWM level is above this threshold, then the switches are enabled. The PWM incoming, remember there's the input thresholds, the input signal amplitude we're going to leave as 5. The reverse threshold, so these are basically at what level, what threshold are these inputs true. So if it's above 2.5 volts, then we're in reverse mode. If it's above 2.5 volts, then we're in brake mode. Otherwise, we're in forward and coast. And now on the output side, the bridge parameters, we're actually going to make the output 6 volts because that's what the motor is rated for. And we're going to leave the total bridge on resistance and the freewheeling diode on resistance at their defaults. Okay, very good. For the PWM portion, we are going to set them just like in the 50 kilohertz, just like in the data sheet. I couldn't find that real quick, but anyway, it's in there. You can read it if you like. We don't really need all of these details because we're going to put it in averaged mode, but it's useful for what we're doing to just see that it's there. For you, if you want to look at some high frequency loading characteristics for your system, you can turn it into that mode. You may need to change some of these to match your data sheet. For us, we're going to leave it in this averaged mode and say OK. OK, so before I forget to do this, I'm going to put these electrical references in here. So they're grounds. And here too. OK. Now, we have, well, I made a little truth table that kind of helps us decode these things. I'll make this a little bit bigger so you can see. Okay, so we need to control ref, reverse, and brake. So I power, reverse, and brake is what they are here. And we have 2 inputs to each circuit, and they're called X-in1 and X-in2. I'm calling them A and B just because it's a little bit easier to keep them straight in my head. So I'm going to have an in1 here, and it's going to be, call this one A. I'm going to call this one B. All right, very good. So the first thing is we need to drive reverse and we need to drive brake. Now this is in the electrical domain. This is a fully electrical block. So we actually need a voltage source. That's not what I want. I want a controlled voltage source. There we go. So this is going to allow me to put in a signal. I'll make this a little bit bigger so we can connect things the way they look right. And we're going to need to do it on both of them. Okay. Now, so we're working our way back to the logic here. We're also going to need one of them up here. This particular one, we don't need to control it, we just need a reference. So connect all those things to ground. That's good. Anything else we're forgetting? I think that's all pretty good. All right, now back to logic. So we know that A and B, if they're, so let's talk about braking first. If A and B are both true, right, A and B, then we want to brake. Otherwise, we want to not brake. We want to coast. So we can use the AND block, and we'll look here in our, where is it, logic, I believe. Logical operator, good. Hide that name. So we can take A and B, make it AND. Now this is going to output, A and B are coming in as something. We haven't defined the inputs yet, but this is going to output a Boolean, and we need to drive this with a double. So there are data types in Simulink. Just most of the time you don't worry about them because things default to doubles. But this outputs a double, so we actually have to convert, let's see, it's data type conversion. Okay, so we're going to take this and we're going to make it, convert it into a double. Format, hide the name. Okay. Now when we convert from Boolean to double, it's going to go from a logical true to a double of value 1. So we actually need to gain that up by 5 because we're going into this HBridge, and remember we set our input thresholds at 2.5, so we'll just kind of make it 0 or 5 volts. So we'll hide that, and this is what, oh, almost got ahead of myself again here. I'm over anxious. We need to go from Simulink to PS, our physical signal, and so we'll hide this name and connect it up. That was break, yep. Now remember, when we do this, oftentimes we need to make sure that we do a little filtering. So we're going to do our typical thing for this. We'll let it filter at 1/100th of a second, so that if there are discontinuities on the analytical side, the physical side will have a chance of being able to stay with it. It'll be smoothed out for it. So there's that filtering. Alright, very good. Now we need the reverse block. So for the reverse, if A is 0 and B is 1, then reverse is true. So we can use another AND block, and we'll copy that and configure it to a NOT block. So remember, we're talking about reverse here. So when A is not true, and B is true, then this expression for reverse is true. So we have to go through the same set of things here. We can copy and paste. Now we can control that. Very good. Alrighty. Now there's one more thing, obviously, here that we don't have yet and we need, and that is motor control. So let's paste another input, and I'm going to call this software motor control, maybe command. Alright, now this software motor command is going to need a lot of the same kinds of signals. Let me show you what I mean by that. We need the same sort of we need a converter again, and we need it to go we need to gain it up by 5 for a reason I'm about to show you. But there's one thing we need to take into account. If we are in 0-0 mode, which is coast mode, we want to disable all the input to the system. So the way we're going to do that is have a dot product to scale it. Okay? Very good. And you say scale what? Well, if A and B are 0, then we want it to be 0. Otherwise, we want it to be 1. So in other words, when when A and B are 0, then we want to scale this by 0. So the other way of looking at that is when A or B are 1, that's the equivalent expression. I think it's De Morgan's theorem. So we're going to model that way. That's nice and easy. One more thing, we have to convert this to a double again. Almost forgot. It'd be so cool if people from YouTube could reach out and correct me before I make these mistakes. That's all right though. So we'll put this double in there. And we want a saturation block. And the saturation block is so we don't overdrive this. And so we'll make upper limit 1, the lower limit 0. This is for the motor command. And hide the name. Excellent. Drop it on. Good. Okay. Now we've created all the logic we need. And it's a pretty good looking diagram. We also want to be able to stop if we're above 1.5 volts, or excuse me, 1.5 amps. So let's go over to this side of the diagram and we'll add a current sensor. So if we exceed that, we'll need a couple connection ports. M plus for motor plus, and we'll make this one motor minus. Okay, now we need to go from physical signal to Simulink, and we're going to convert using units of volts, and we'll hide the name of these two guys, make it look pretty. Okay. Okay, now it can be positive or negative because of this HBridge can go either direction, so we'll use an absolute value block, and then we're going to use something we haven't seen before, stop simulation block. So if that actually happens, we'll stop the simulation. Alright, so this all looks really good. Double check that I didn't forget anything. Oh, I did forget something already. Okay. At 1.5 or negative 1.5, we need to compare to constant and check and see. If it is greater than 1.5, output type is a Boolean. That will get us what we want. Very good. All right. So I'm going to save this as HBridge 2. And if I'm perfect, then I'm perfect. Hopefully I am. We live in hope. And we'll just make this stuff a little bit more compact. Good. Alright, this is a good looking circuit. Save it. Alright, now we need to test and make sure it works, right? So let's put this all in a subsystem like we learned how to do a time or two ago. And we'll put M plus and M minus on the right hand side so that that looks right. Good. Alrighty. So we're close to having an HBridge here. HBridge control. We don't need the ports out here, but what we do need is some constants to test this thing out. So let's try it. Now we're going to start in forward mode, and I'll copy the our little cheat sheet here. So forward is 1, 0, and then we're going to feed in a command of, let's just start at full blast, 100%, 1. All right, now in order to test this, we also have to have a voltage sensor. Okay, and what we'll do is connect that side relative to that side. Oops, you know what? That's better. Positive side to positive. That will come out looking better. We're going to need a solver outside of this thing too, because this is a brand new model. And then we need a PS to Simulink converter so that we know what units we're talking about. Volts. And good. All right. We'll hide the names. Keep it pretty. And then we'll put a display on here because we're not really doing anything dynamic. So what should happen if we did everything right? We got our fingers crossed, right? A and B are in 1-0 mode, which is forward, and we're giving a 100% voltage command. And you'll recall that the HBridge output voltage is 6 for 100% voltage command. So we should see a 6 here. So let's, and it says this one cannot be volts, and that makes sense. So we should make that amps. Good call. All right. If I run it again, 0. Why on earth are you 0? That's connected to that. I have this connected to the wrong reference. That always gets me on this block. Ground was connected to PWM instead of to reference, so everything we do is going to come out as 0. So this should give us a 6, and lo and behold it does. Goodness gracious. Okay, so now let's make a copy of this and see what the other side is. We connected it to ground, so we expect it to be ground. So let's try 0, 1, which is reverse mode. And this should be 0, and this should be -6 this time around. And it is. Okay. Now 0, 0 should kill the motor command and put us in coast mode, which it does. And 1, 1 should put us in brake mode, which it does. Okay, now one more thing I want to try before we leave is half. So this is half power. Output at 100% is 6 volts, so we should get an output of 3, which we do. And if we go back to reverse, all right, 3. Okay, and I'm going to take this guy out. I was troubleshooting that. Good. Everything else is good. And yeah, and in the process of troubleshooting, I also show you a little trick here. You can show the value label at select ports, so you can watch what's going on. Really good to troubleshoot with. Okay, so now we have a working HBridge, and all we have to do actually is copy, go back into our HBridge section, paste, and now we have HBridge 1 and 2, and we'll get our connections all sorted out later. But that's it for the HBridge stuff. Thanks a lot for watching, and I hope you enjoyed all of the all the challenges. Hopefully you won't have to watch all of it. I'll edit them all out. Anyway, it's all good. Thanks for watching. Comment, like, subscribe, all that good stuff. Let me know what you like and what you don't like, and I'll do my best to give more what you like and less of what you don't. Thanks.